Okay, here's 5.4 homework problem number 12, and I'm going to show you the problem in the book and try to come up with a diagram for this. A little bit going on here, and the B is really the writing to learn. There's really a lot of thought going into that one. We have a volume given here, an open top rectangular tank with a square base X feet on each side and Y feet deep. So get a reasonable diagram for this. Give it some dimension here. So Y feet deep and X on each side, an open top rectangular tank with a square base X feet on a side, Y feet deep, is built with its top flush to the ground. So we're digging this thing into the ground to catch runoff water. The costs associated with the tank involve not only the material from which the tank is made, but also an excavation charge proportional to the product, XY. All right, so we are given the cost is 5 times x squared plus 4xy plus 10xy. So that is basically cost as a function of x and y. But what we also are given is that the volume, which is x squared y, is equal to 1125 feet cubed. So these guys are feet. Help me remember that. Right. But again, I don't want cost as a function of x and y. I want cost just as a function of x or just as a function of y. So easy to solve for y. 1125 on x squared. So cost as a function just of x is 5 times. Actually, I think I'm going to simplify this one step because I noticed this. I've got 5x squared plus 20xy's plus 10xy's plus 30xy. So I get 5x squared plus 30 times x times y, which we're replacing with 1125 on x squared. Or we get 5x squared plus, 3 times this is not too bad. Let's go ahead and just do this on calculator. I'm feeling a little lazy there. 1125 times 30. I get 33,750. X cancels an x, all on x, and that is our cost just based on x, which we're trying to minimize, which makes sense because this kind of has sort of a parabolic feel to it, although there's some other interesting things going on here. Right side up parabola. But let's go ahead and find our derivative. C prime x is 10x, if this is x to the negative first, minus 33750 on x to the second. And if I want to set that guy equal to 0, the first thing I would do here is multiply both sides. Oh, this is just, yep, that's x squared. I multiply both sides by x squared. And I get 10x cubed minus 3375 equals 0. That's 50. 50 equals 0. X cubed is 3375 after I divide by 10. And x equals, please, 3375 raised to the 1/3 is 15. Yay. X is 15. So x is 15. This is our critical point at 15. Come back up here and we get y equals 1125 divided by 15 squared. So 1125 divided by 15 squared is 5. So x is 15, y is 5, gets us our volume, minimizes, and the B question then asks, give a possible scenario for the cost of function A. 5x squared plus 4xy. Let's look at x squared plus 4xy. X squared plus 4xy would be our base times, let's see, x squared plus 4xy. We're taking a look at this. Sorry. There's our base, x squared, and xy and xy. That's our total area. So this cost function looks like this would be like 5 times the total area, and 10xy. Well, xy is one of the is the area of any one of the sides. So this could be $5 for the area plus $10, like total area including the bottom, plus $10 for our excavation cost. So let's read this again. The cost associated with the tank involve not only the material from which the tank is to be made, so that could be $5 times our total area, that's the tank is made, but also an excavation charge proportional to the product of XY, so time plus $10 times this little cross section. You know, we just have all these little cross sections going down through here. So plus $10 for just the excavation charge. $10 times the amount of excavation based on the area of one side. Something along that line. So kind of a lot going on there, thinking of that through B. Again, we could come up with a graph for this. Wouldn't be a bad time to grab graphing calculator and just check this, take a look at what it looks like. So let's go ahead and do that to get comforted here by this solution. I'm going to darken this up just a little bit for you. Clear this past brown mount. We got 5x squared. Clear that. That's now good. 5x squared plus 30x times 1125 divided by x squared. And I'm going to just go, I expect my answer is 15. I'm just going to go 0 to 25. No real reason on the 25, just it's beyond 15. 25 and zoom 0. And there we go, and I notice this guy starts to pop up here just a little bit at the end. What I might want to do is take a look at my window, and wow, my Y values are pretty darn big. I might just zoom box this thing. Let's go back to graph, and let's zoom box this just to kind of accentuate where it looks like it's hitting a minimum. So I'm going to stay pretty wide here. Hit enter here. I'm going to go all the way over down as far as it allows me and enter. We could have done without that, but it just kind of shows the curve where we're hitting a minimum value. So let's go second calc minimum. And I'm really hoping we end up with 15 here. And not only do we get 15, we get the $33.75, which is our minimum cost. So the cost associated with each tank, we've got it. What value of X and Y will minimize it? The values for X is 15. Now Y, that's a different Y than ours. That Y is actually the cost. Our Y value was 5. So 15 and 5. Okay, hope that's helpful.